and this week's video is going to be all about simple probability. I'm going to be solving some questions and defining a few basic ideas about it. And basically, simple probability is just when you have a specific outcome, and in order to get the probability, you divide it by all possible outcomes. So, as you can see over here, this is the formula. This is the probability of the variable a, and it would equal to the n, which n means the number of a's out of the number of possible outcomes. So for example, easiest is an example with a die. You have a 6-sided die. There's only one side with a 6, and there's 6 sides total, so your probability of rolling a 6 is equal to 1/6, right? Because you have one side with a 6 and you have 6 sides total. So, for some further information, when we use set notation, this right here is set notation, we use symbols such as these. So this upwards U-like, this is a union. This means if you have A union B, that means everything in A plus everything in B. So if A is 1, 2, 3, B is 3, 4, 5, AUB would equal to 1, 2, 3, 4, 5. You do not repeat the 3. And then the other one, which is an upside down U, this is the intersection. So if we go back to the example about A and B, A intersection B would be the 3, because this is the one that they share. This is the one that intersects. And the last one, which is like a straight line, this is the given symbol. So, and this one is a bit more complex, so I'll only brush over it, but it is an outcome given that the other one already happened. And we'll get into that a bit later because there will be an example coming up. So first, let's start off with a very basic question. We have to find the probability of picking a red pen out of a bag containing 3 blue, 7 yellow, and 5 red pens. So let's define some variables. Let's say that the blue pens are going to be our B, the yellow pens will be a Y, and the red are going to be an R, right? So going back to our, first of all, logic, and second of all, what we know about simple probability, the probability of getting an R would be, we have 5 red pens, right? How many do we have total? We have 3 plus 7, 10, plus 5, 15. So we're going to have 5 red pens out of 15, right? This is what we want, but this is all of the total. We can't always get what we want, so we have to divide it by the total outcomes that might also happen. And if we simplify this we just get 1/3. So the probability of getting a red pen, of picking a red pen, is 1/3. All right, this one is another case of simple probability, and simple probability is often also represented in diagrams. So here we can see the numbers of students taking biology, let's define that as B, chemistry, let's define that as C, and physics, let's define that as P, and do not get mixed up with the P from probability and the P from physics. And here, as you can see, we're missing something. And we are given that there are 50 students total. So let's look at the questions. The first question is to find, and let's apply our set notation theory. We're asked to find the number of elements in biology intersecting with C, intersecting with P. And what does that mean? That just means something that they all share. And because it's the number, we want to find the number of students that take biology, chemistry, and physics. And this 50 students total helps us a lot, because now we can say, all right, so all of these values over here must add up to 50. And 7 over here, this just means that 7 don't take anything, right? So now we know that everything over here adds up to 50. And if we add 10 plus 2 plus 9 plus 4 plus 1 plus 12 plus 7, we're going to get a 45. So what's the number missing? 5. And there's only one place where it can go, over here. So this is what we will have. So to find this, we know that it's going to be 5. And to find this, what we did is we did 50 minus 10 minus 2 minus 9 minus 4 minus 1 minus 12 minus 7. This would all equal to the number of elements in the intersection. So now let's find the probability of having a student that takes biology and physics. This intersection is like an and physics. So let's find here. This is biology, this is physics. Where's the intersection? Right here. And you must not ignore what we just found. That's why we found it first. Because even though this question asks for biology and physics, it does not say that the student cannot take chemistry, right? So we have to take into account this number right here too. Don't forget about it. It's not just this, it's also this number right here, because they also do take physics and biology. So we have 9 out of 50, because we know that the total number of outcomes is 50. Now let's find the probability of a student taking physics. This P is for physics. And physics, we can see that we have students who take physics does not mean that they cannot take another science. So we can assume that we can include all of these numbers as well. So we're going to have 12 plus 4 plus 5 plus 1, which is 22, over, once again, 50, because that is our total number of outcomes. Now here, the next one is a bit more complex. Here we want to find the probability that a student takes physics, given that they take biology. And the key to understanding this is whenever you have something that's given, you take that as your possible outcome. That is your sample space. We're given that we have biology. So what do? We have to discard everything that's not biology. Chemistry does not exist in this problem. Just physics by itself does not exist in this problem. And not taking any science does not exist in this problem either. All we can look at is biology right here. This is all the question asks of us. So our sample space is reduced to only biology. It's given that biology has for certainly happened. We know that the student is in biology, so we can discard all of the rest. And we want to find the probability that they take physics. And this is, once again, just the intersection over here. So we have 9, but be careful, because now we don't have 9 out of 50, we have 9 out of biology. And here, in biology, you have 10 plus 2 plus 9, you have 21 students. So you're going to have 9 out of 21. And if you simplify that, you get 3 over 7. Lastly, we have a question that says that 2 students get picked, and let me highlight this, after another. Find the probability that both take chemistry. The after another is really crucial to understand. Here, after another suggests that once we pick that student out, they're not replaced, they're a student. That doesn't work that way. So what does that suggest? That our sample space is going to be reduced by 1. And let me show you what I mean. So first, it's just normal. What's the probability of a student taking chemistry? Well, that's going to be 9 plus 2 plus 1 plus 5. 17 out of 50. So first, our first probability is going to be 17 out of 50. Then we also have to find the probability that the next student will also take chemistry. And here we're timesing the probability because we want something quite specific. And the more specific it is, the harder for it to happen. So we have to times the probability because it's an and problem. We don't want the first or the second, we want both. So we have to times the probabilities by each other because we want both occurring. And it's not one or the other, it has to be both. So we are timesing the probabilities by each other. But the second one, we're going to reduce our sample space because first we had 17 students, right? But by the time we arrive to this student or this sample space, one chemistry student is already going to be gone because we took them out since we have to have both chemistry in both trials, right? So now we're going to have 16 chemistry students out of 49. Why? Because once we took this out, we didn't only take them out from chemistry, we took them out from the whole sample because chemistry is part of the whole sample, right? So what is going to equal to? 17 times 16 is 272, and 50 times 49 is 2,450. And this is, the probability is a fraction, and this is not a simplified fraction, as you can tell. But we can also express probability as a decimal. But this, be careful, it's not as accurate. So we can say that the decimal is 111. This is what you get. And we can convert this to a percentage and say that the probability of this happening is 11.1%. All right, so I hope you now are more familiar with simple probability. I hope you're more familiar with set notation. It's really important to understand. And this is just a brief introduction. There's a lot of ways that simple probability gets used, a lot of ways in which it gets represented, and I hope you enjoyed. See you next week.